Hello guys, welcome back to mathematics. Today we are going to learn how to add and subtract fractions. We are going to check different cases. We are going to start with same denominators. We are also going to check when they are different, but one is a multiple of the other one, and what happens when they are not multiples at all. And at the end, I'll give you a bonus that is going to help you to any of the cases. So let's start. When they have the same denominators is the easiest one because that means you are adding pieces that have the same size. For example, in this case, 3/5 plus 1/5. So it's telling you that from a whole divided in 5 parts, you have 3 parts and you just need to add one more of the same size. At the end, you are going to have 4/5. That means the only thing you need to do is to leave the same denominator and you just operate the numerators. 3 plus 1 is 4. And that's how you are going to get the 4/5. In the case of the subtraction is something similar. We have the whole divided in 7 parts. We have 5 of them. And we are taking 2 away. They have the same size, so I can just take away the 2 slices. That's it. So, same denominator, 7. And then I just operate the numbers at the top. 5 minus 2 is 3. That is the 3/7 that you see in the representation. So this is the easiest case. That's why I started with this one. Let's check what happens when they have different denominators, but one is a multiple of the other one. In this case, we need to use equivalent fractions. Remember, with equivalent fractions, you can multiply or divide top and bottom by the same number to get another fraction that is equivalent. That's what we are going to do in these operations. They have different denominators, so we cannot add them together because the slices in this one, for example, are smaller than in this one. In this case, this one is just one slice, but it's bigger than the other ones. It's like a double. So what we do is to find an equivalent fraction so they are going to have the same size. If I divide each piece in 2 parts, then I'm going to have the same size of the slices. With equivalent fractions, that means that we need to multiply by 2 these fractions. So I'm going to get an equivalent fraction, in this case 2/10, that is going to have the same denominator as the other one. So I can write this operation as 3/10 plus 2/10. 1/5 is equivalent to 2/10. Then I can do the addition from here. Same denominator, I just leave it, and 3 plus 2 is 5. Same thing in this case. Notice 14 is a multiple of 7. So again, we just need to multiply by 2, top and bottom, for this fraction to get 5 times 2 is 10, 7 times 2 is 14. This one is equivalent, but now it has the same denominator as the second one. That allows me to do the 14 in the denominator and just 10 minus 2, which is 8. Remember, when possible, we need to simplify this, also with equivalent fractions. In this case, we are going to divide by the same number, top and bottom, to get 4/7. 8 divided by 2 is 4, 14 divided by 2 is 7, 4/7 is equivalent to 8/14. So this is the result, 4/7. And let's don't forget that for this one is 5/10. We can also simplify this one, dividing by 5. We are going to get 5 divided by 5 is 1, 10 divided by 5 is 2. So the result is 1/2. Remember that this number could be any number as long as we can divide both top and bottom. In this case, they are both multiples of 5. That's why I used the 5. 5 divided by 5 and 10 divided by 5. That's 1/2. Let's see what happens when they have different denominators and they are not multiples of each other. In these cases, we need to find a number in the table of the denominators. So what number is in the table of 4 that is also in the table of 6? Yes, very good. The 12. The 12 is in the table of 4 and also in the table of 6. So I need to multiply by a number that gives me that 12. 4 times 3 is 12. So that means I multiply by 3, top and bottom. Remember, always by the same number. And for the 6, I need to multiply by 2 to get the same 12. So in this case, I multiply this one by 2. Let's check what we get. 3 times 3 is 9 over 4 times 3 is 12. So I get this other fraction that is equivalent to the one that I have, but then with a denominator of 12. Same thing with this one. 1 times 2 is 2. 6 times 2 is 12. Now I have two fractions with the same denominator. So I leave the same denominator and 9 plus 2 is 11. Remember always to multiply by the same number, so the fraction is going to be equivalent to the one that we previously had. Now let's check this one. In this one, the number that is in the table of the 7 and also in the table of the 3 is 21. That means we need to multiply the 7 by 3, so this one also by 3, and this one by 7. So same number at the top. We get 5 times 3 is 15 over 3 times 7, which is 21, minus 2 times 7 is 14, and 3 times 7 is 21. Again, we have the same denominator, so we just leave it, and we do the operation with the numbers at the top. 15 minus 14 is 1. So we are going to get 1 over 21. And for the next one, 11 over 12. Those are the results. Let's see the bonus. It's the happy face. And it works for all the cases. For any addition or subtraction of two fractions, you can use this happy face. It's called happy face because you are kind of draw a happy face here. You see it? It's like it's laughing. You know the face that is laughing like that? Then it looks similar to that one. That's why it's called happy face. So every line is a multiplication. The eyes are going to be at the top and the smile is going to be at the bottom. The eyes means that we are going to multiply 3 times 5, put it at the top, plus, because we were doing an addition, 10 times 1, which is 10, over, and the number that is going to be at the bottom is the multiplication of 10 times 5, so 50. And then we do the addition. 15 plus 10 is 25 over 50. We can simplify this by dividing by 5. That's going to give us 5 over 10. And notice that we actually could divide by 5 again. Equals 1 over 2. So the answer of this addition is 1/2. Let's do it with this one. So again, 5 times 3 is 15. 7 times 2 is 14. Remember, since it was a subtraction, we keep doing the subtraction. Over 7 times 3, which is 21. And the result is 15 minus 14 is 1. And 1 over 21 is the result. Okay, at this moment you should be wondering, but if the happy face is for all of them, why should we learn the other ones? I'm going to show you how would be the same operation, but using one of the methods that I previously told you. Instead of using the happy face, I'm going to say that 10 is a multiple of 5. So I'm just going to multiply by 2 this fraction to find an equivalent one with a denominator of 10. Plus 1 times 2 is 2, 5 times 2 is 10. So notice here that they already have the same denominator, 3 plus 2 is 5, and then we can simplify dividing by 5. So this is equals to 1 over 2. Yes, same result. It's just that notice that using this method, we got like very big numbers, and sometimes these numbers get really big, and then the simplification gets harder. In this case, we have to divide by 5 twice. In this one, we had to divide just once. That's the difference. For some operations, the happy face gives you two big numbers, so it would be better to use an alternative method. But if you don't remember how to do this, because that happens sometimes, then go with the happy face. You are going to get the same result. It's just that you are going to have a little more trouble simplifying, but the answer is the same. Now, guys, this is your time to practice. I have these four operations for you. You can pause the video, and in a moment, I'm going to give you the answers. Okay, remember that if you got fractions that you can simplify, you should simplify because I'm giving you the results after the simplification. So check your answers. Okay, guys, I hope you learn a lot with this video. Don't forget to subscribe, give me a like if it was useful, book your own lessons with me if you needed to, and remember to drop any questions, suggestions, maybe a topic that you want me to explain in the comments box. Okay, guys, bye bye. See you next time.